Hi everyone, welcome to 4J. This is Joash, this is Chi, I'm Wei Jie, this is Brandon Yu. So we're going to make a motor of a fan, and below we'll show you how it's done. Yeah.
Firstly, we coiled the thinner insulated copper wire around the diameter of the large magnet for about 12 to 15 rounds, ensuring the coil resulted would neither be too light or too heavy. Then we repeated the same step for the thicker insulated wire. This is to make sure we can find out which type of insulated copper was more reliable to use. We made sure that our entire ring structure was sandpapered as well as adequately balanced. For example, we ensured that the wires extending from both sides were of equal length with each other, thus ensuring the ring was balanced.
Secondly, we bent two paper clips so that their new shape will be able to hold the coil firmly above this. Above the ground yet still be able to stand firmly when clipped by the crocodile clip. Our choice of using paper clips as a support for the copper wire is because we want to choose a conductor that can be part of a circuit and yet be cost effective, as a stand can be molded to our preferred shape. We pick a paper clip that is strong, as it is needed to withstand a magnet pull without the paper clip bending out of shape, and ensure that the copper ring is absolutely stable. Initially, we found that the paper clips were very tough, proving difficult to bend, but in the end we used a pair of scissors to bend it, and we bent it like a cradle so that it can support the ring and stand on its own.
Thirdly, we placed two AA batteries into the battery holder. Then we clipped two of the crocodile clips to the battery holder. The other ends of the two crocodile clips were clipped onto the two paper clips bent earlier, which the coil wire is resting on, such that there is a complete electric circuit and electricity can flow from the positive terminal of the battery to the negative terminal. A group member will then move the large magnet under the coil wire slowly. Meanwhile, another group member has to use both his hands to hold the paper clip down. This proved to be a daunting task, as not only does he have to ensure that the paper clips stay straight so that the coil wire does not fall off, he also has to ensure that the paper clips do not get attracted by the strong magnet. Thus, he has to provide much strength to resist the great magnetic force. If the coil wire starts spinning, the motor is complete.
After many rounds of troubleshooting, we demarcated areas where to place our magnet, copper coil, and paper clip, so that similar results can be reproduced. To keep our parts in place, we decided to tape our parts on a corrugated plastic sheet so as to keep the setup hands-free. The corrugated plastic sheet also provided a backing to ensure that our parts do not overlap, as well as keeping the setup portable while not falling apart. Concepts. In the circuit, current flows from the positive terminal of the battery through the circuit and to the negative terminal of the battery. This current creates a magnetic field, which can be determined by the right-hand grip rule. By making a thumbs up sign with your right hand, the thumb points in the direction of the current, and the curve of the fingers show which way the magnetic field is oriented. The wire, coil, and paper clips create a closed-loop circuit that allows current to flow through. The current travels through the coil, which induces a magnetic field in the coil. Because the magnetic field created by the current in the coil is not perpendicular to the magnet near the coil, some of the coil's magnetic field will repel, which results in it spinning. The reason we remove insulation from only one side of the wire is to break the circuit periodically so that it pulses on and off in time with the rotation of the coil. Otherwise, the copper coil's magnetic field will align with the magnet's magnetic field and result in attraction between the copper coil and the magnet, stopping the coil from spinning. When the uninsulated parts of the coil come into contact with the paper clips, current moves through the coil and gives the coil a magnetic field. It repels it from the stationary magnet's magnetic field. During those split seconds, when only insulated parts of the copper coil touches the paper clip, the circuit is open and no current will flow through the copper coil. Although there isn't a magnetic field to repel that of the magnets, momentum carries the copper coil around until the uninsulated parts come into contact with the paper clip, inducing another magnetic field, which causes the copper coil to be repelled again. The cycle continues, resulting in the copper coil's continuous spinning. Once moving, the coil can continue to spin until the battery is flat. The reason that the copper coil only spins in one direction is because spinning in the other direction will not cause the magnetic fields to repel each other, but to attract.
Apart from a fan motor, DC motors can also be used in electric cars, Segways, Dyson vacuum cleaners, DVD players, and washing machines.
As the physics performance task will require many aspects to be completed, We had to split up the job in order to complete the project in time and with flair. Brendan New decided to volunteer to go to various places to buy the apparatus required. Then, he would help in collating the photos and videos taken to fit them in our group's video. Wei Jie utilized his prior knowledge regarding the concepts behind the model to complete the model properly and with flair. Thus, he was in charge in experimenting the model together with Chi and Joash, making appropriate changes to the model to make it more stable and reliable. Chi's main roles are to record the videos and take photos, and also to come up with the report, which he will work closely with Joash, as Joash is the editor of the report. Now moving on to our acknowledgements. Our group would like to thank our physics teacher, Miss KIQ, for invaluable insight and knowledge, and also for allowing us to use the physics lab on 10 April for the testing of our model. We would also like to thank our families and friends for helping and supporting us in one way or another. Thank you.